Hello everyone, welcome back to my channel. Today we are continuing our topic, which is forces and motion. For all of you preparing for your mock exams, I'm creating a special series that will focus on important and challenging questions. I'll start posting those videos from next week and I'm sure they'll be very helpful for you and for your preparation. If you have any doubts or questions, please feel free to ask me in the comment section. I'll be very happy to help. Well, let me start with the types of forces and also the free body diagram that we will be discussing in today's lecture. Now, forces, as we have already discussed the three laws of motion, so now you might be having a good idea what is force actually. Or in short, I can say any pull, push, they all are basic a force. Not always the force results in pulling or pushing something. Many times it can change the shape and size, and that we will be doing in forces and elasticity. That force which results in moving something, stopping something, that will be here in forces and motion. So let me see, the forces are of two types, contact forces and non-contact forces. As the name suggests, we can see that contact, that means the force that needs a contact in order to impart. If you want to push someone, you have to touch him. So that's called contact force, where you have to make some sort of contact. And these ones that I'm going to discuss are the types of contact forces. So the first one is the friction. Well, first of all, important thing is you have to understand that the friction is a negative force. A negative force, that means which always opposes your motion. If you are moving in forward direction, then friction will be in opposite direction. And that's why when you move on a harder, very rough surface, it becomes much more difficult for you to move. Whereas if it's a very slippery surface, you can easily slide over there. Because on slippery surface, we have a very less friction, and whereas on a rough surface, we have more friction. Now let me understand what exactly the friction is. I told you it's a resistive force. It's an opposite force, and where a surface is required, a solid surface is required for that. On a microscopic level, if I explain you the friction, there are very small pores. This is about the microscopic level. On macroscopic level, on a bigger level with our naked eye, if I see, I won't be able to find those very small ridges, peaks there, but it is present. So suppose this is the surface, or let's say this is the floor on which you are moving, and there is another surface, that's your shoe. So the shoes, they seems to be very, you can say, very smooth, but they are not. Even if you're using some very slippery ones, still they have those ridges. So sometimes what will happen, sometimes I mean like at some places, the interlocking will happen like this, and see here. This pink represents the surface of your boot or the shoes or your feet, and this black one represents the texture of the surface of the floor. Now, when you step on it, there will be the interlocking at some places. And when you try to move yourself, these interlocking actually creates problem and makes it harder to move in forward direction. As the surface becomes more smoother, these peaks, ridges lessens, and that decreases the interlocking. And that's why I told you on slippery and smooth surfaces you can easily slide, whereas on a rough surface it's harder to move. So this is about the friction force. Now the next one is, here in the diagram you can see the driving force in a forward direction, and that friction is opposing its motion. Next is normal force. Now, if there is a gravity on earth, so everything has a weight which has a mass. That means we know that weight is mass times gravity. So everything which has a mass definitely has a weight. That means it will exert a downward force. This one here. Say for example, this is a book resting on a table, and obviously the book has a mass, and similarly it has weight. So weight is always towards the earth in downward direction, and that's why it will be like this. So the force that opposes your weight, that will be your normal reaction force, normal contact force. And this is generally between the solid surfaces. This book is a solid one, this table is a solid one. So when the book is exerting weight on the table, the opposite force given by the table is this normal reaction force. Now understand why it's happening, because say for example, if table doesn't push book upwards, then your book will crumble inside the table. So in order to be there to like sustain that everything, the table has to apply an equal and opposite force, and that's your normal reaction force. And you can clearly see the contact is very important, hence it's a part or it's a type of a contact force. Next is a tension force. The word tension means stretching something. If you are stretching something, that's called your tension force. So if something is hanging on the wall with the help of a rope, a string or cable, and it's pulling it downwards, suppose you have a rope and you have attached a weight at its end. So obviously that's an extensible thing. That means you can extend it. So this weight at the end of the rope will exert a downward force, which results in stretching this one as well. So this rope or whatever extensible ring you are using, or inextensible ring you can say wire you're using, it will pull downwards along the weight of the object. But this is the nature of the objects. They resist the change, and that the molecules, the atoms of the string will try to regain their initial position. They don't want to get stretched. So they apply an opposite reaction force, which is called tension force. So this is your tension force generally in rope, strings or cables. Next is air resistance or drag. So air resistance is the force that opposes the motion of the objects moving through air. So they have to be in that. So say for example, let's take an example of an aeroplane. Not necessarily which has to be in the air only. Even if you are driving, you will feel, because some of your part faces that air. So when you move in a forward direction, all the molecules of the air will oppose your motion, because they have arranged themselves in such a way, like they have already scattered like that, and then you are moving through them. You're just disturbing their configuration, so they will try to resist that change and will exert an opposite force, which is your air resistance. So in this diagram, you can clearly see that this is the driving force. Take an example of aeroplane. Aeroplane is moving in forward direction, and air resistance or the drag is opposing in opposite direction. And this is actually the weight, because everything has the weight. So aeroplane has the weight, and the opposite is the lift force, which helps it in keeping itself in the air. And that now we're studying the next force, which is the lift force. So a lift force is the upward force X on an object moving through the fluid. So yeah, it can be fluid. That means a combination together, the liquid and the air, the gases are called fluid. So that is keeping itself upward. Generally for the liquids we use the buoyant force actually, and for air specifically we use, or the gases we use, the lift force. So upward force that is acting, which is obviously in this case opposing the weight. Heavier the weight, more will be the lift force. So in this case, this is opposing it. Now the next is the spring force. So spring force is basically a restoring force exerted by a compressed or a stretched spring. And these basically are, there's so many other types, but these are the main, you can say, contact forces that we will be studying. And why we are doing, because these are very important for the study of the free body diagram. So this spring force is simply a restoring force. It has been restored in it, and when we stretch any string or any elastic material, or when we compress it. Now next is non-contact forces. Now the non-contact forces, that means they don't need any touch or sort of contact. So obviously the very common is the gravitational force that you feel every time, that helps you maintaining yourself on earth, you're not flying up. So it's basically the attraction between the two masses. Not necessarily only we are feeling, even all the celestial bodies feel that one. It all depends on the mass basically and the distance between them, and that actually makes the force more stronger or weaker. So the gravitational force is basically between the two masses. More the masses, more will be the gravitational force. The next is, here you can see, is the magnetic force. Obviously it's the attraction or the repulsion between the magnetic poles. So that's also, it doesn't require any contact. The magnetic force can be experienced from a distance. So magnetic force is between two magnets, and it can be repulsive or attraction force, and as well as between magnets and the magnetic substance, and they always attract each other. I mean, basically the magnet always attracts the magnetic substances. The next is electrostatic force. Electrostatic force is the attraction and the repulsion force between the charged particles, between like the protons, neutrons. These are the charged particles. So if you bring charges like proton together, electron together, they'll repel, and when you bring the opposite charges, they'll attract. Next one is the nuclear force, and this is a very strong attractive force between the protons and the neutrons. Now just think, because inside the nucleus we have all the positive charges and neutrons that are neutral charges, and I've just explained to you by the electrostatic force that they should repel with each other. So that means nucleus should fall apart, but it doesn't happen like this, because there is a very strong attractive force between the protons and neutrons that are gluing them together, overcoming that electrostatic force, and this is the reason it's the strongest force. Now let me move on to the free body diagram. So free body diagram is a simple sketch of the objects and all the forces acting on it, and that helps us basically in the calculations. So what is the purpose? Here written, what is the purpose of the free body diagram? It's to visualize the forces clearly, to analyze the motion or the equilibrium of the object, and to apply Newton's law of motion easily. So now let me see how we can draw free body diagram for each object. Now, as I told you that the free body diagram is always where you have to represent all the forces acting on particular object. When you are drawing a free body diagram, the first thing is you don't have to draw that object. If suppose there is an aeroplane, you don't have to draw the aeroplane. Just represent that object with a point, just like this one. That's it. And then all the forces in a perpendicular direction, that means in forward, backwards, upwards, downwards, in a straight line, and pointing their arrows so that you know that in which direction the forces are acting. And this is your free body diagram. The first example is a box resting on table. A box resting on table has only two forces, the downward weight, and I told you because this is a table and the box, and they both are solid, so there would be a normal reaction force opposing your weight, and that would be upwards. So basically one that you can see here, this one is the free body diagram of a box resting on table. The next is a submarine in water. So obviously here the submarine is moving in forward direction, and that forward direction is a driving force, or you can say a thrust required. So that's given by the engine of the submarine, and it's moving in a forward direction. But since it's moving in through the water, so water molecules will exert the opposing force to that, and that's your water resistance. Just like in the air it was air resistance or the drag, here is the water resistance. Downward is always the weight, but don't do a normal reaction force because it's between the two solid surfaces, water and the submarine. They both are not solid, water is liquid. So the upward force in this case will be a buoyant force. So buoyancy is the upward force basically given by the liquid. Now the next is aeroplane in the air. So here, just like the submarine, it has a thrust or the driving force in the forward direction given by the engine, and since it's moving through the air molecules are opposing the force, exerting an opposite reaction force basically, and that's the drag, the negative force. That's the drag or the air resistance. Aeroplane also have the weight, so it will be in downward direction, and something that is equalizing its weight, because if there would be nothing it will fall down. So to maintain that there has to be some force to keep maintained it in the air, and that's the lift force, which is in upward direction. So this was about the free body diagram. I hope you have already understood this, and that's it for today. And in the next class we'll be continuing with the forces and motion, and also we'll be doing questions on these concepts that we are learning. If you're looking for one-on-one live online classes or the group classes for GCSEs, they're very reasonable, starting from at just £6 per hour, and I teach maths and physics, and my tutors take care of other subjects. And not only for GCSEs, we teach from A1 till A levels, and we have subject matter experts. We do have the university students as well, and highly expert tutors as well. And like university students also have minimum experience of 3 years, and they are in one of the top most you can say the top universities of England, and also they themselves have already studied from the good grammar schools, so they know the preparation. They have scored good grades in their GCSEs, so, and they are very affordable, to be honest, very affordable. So to book your free slot, all you need to do is just email us at exactacademy@gmail.com. You can check our website as well, which is www.exactacademy.com, and you can access the free worksheets there as well. And we do have app as well on Apple Store and on Android Store as well, Android Play Store. Okay, so that's it for today. Bye everyone, take care.